the first part of this is going to just be kind of a quick little PowerPoint presentation. I was going to do a Prezi and be cool like Chris Halsey, but I started it and it was just too much time. I just wanted to throw slides together. It was too much work. So I'm a programmer. That by definition, that means I'm pretty lazy. So you're not getting a Prezi, you're getting a Google presentation. So intro to C#, cool nerd stuff. So before we get started, oh, I didn't finish my thing. I'm sorry. So we're going to do a quick presentation, kind of get some groundwork laid of what a program is. This should be done in just about 5 minutes or so, and then we'll move right into creating a little console application. So let's see how long this takes. We got to do some housekeeping terms, or do some housekeeping first, get some terms out of the way. What is a programmer? They are people who fix problems you didn't know you had in ways you don't understand. Very important term to understand. There's also the algorithm. The algorithm is a word used by said programmers when they do not want to explain what they've done. Very important. Hardware.
That's perfect.
Right? I probably didn't want Margie to know that, or Brian didn't want Margie to know that.
You guys don't know that secretly I'm part programmer because I use that word all the time for the same reason.
There you go. It's a great tool. Hardware. Hardware is that part of the computer that you can kick. So if you can kick it, it's hardware. Some social housekeeping. How can you tell introverted from extroverted programmers? This is important to know. It's a good skill to have. The extroverted ones look at your shoes when they are talking to you. They actually look at your shoes. Thought that was pretty funny. And then finally, we got to get some medical terms out of the way, or some medical issues. Why do Java programmers wear glasses? It's important to know if you're going to be in programming. It's because they can't C#. C#. Okay. I think I just heard a real cricket. All right, real terms. Did you do it?
We're laughing on mute. We have to develop a signal for how we laugh on mute.
I think Eric, did you play real cricket?
No, I actually laughed. That was a good joke. I got that one.
Okay, I also heard a cricket inside my head. That was so weird. So real terms, real boring terms. C# is a programming language that we use to write programs. Obviously, there's a lot of languages out there that we could have chosen. One of the most popular ones right now is C#. It's easy, it's nice, it's elegant. It's very similar to Java. It's similar to JavaScript in the way it looks. There's also C++. There's difficult ones that are a lot more low level into what the computer can do, like C++, C. And then there's a million other different crazy offshoots or programming languages we could use. But Microsoft created C#. It's an elegant language and it works really well with their systems. There's ASP.NET. You've probably heard that floating around. That's the web technologies. That's the combination between the web technologies such as HTML websites and stuff like that with the programming languages like C#. You can use different languages. You can use Visual Basic with ASP.NET, but the combination of the web and the languages smushed together helps you produce the web applications. That's really the ASP.NET. That's what it is in a nutshell. There's a lot more technical definitions I could have used, but that's really what it is. None of what I'm telling you is going to be 100% technically correct because I'm going to just try to use simplified terms. So I know Brian's probably rolling his eyes on some of the stuff like, oh my gosh, but this isn't for nerds. This is for normal people. I got this. So if you want to see what the old school HTML used to look like, I found a website that still works from the 80s. This is literally the Warner Brothers You've Got Mail website, and I can post this in our Slack channels later. If you really want to remember what it used to be like before ASP.NET and web apps, you can see where Tom and Meg are trying to start a relationship on this beautiful website. Visual Studio, that's the application that we use to write code in. We call it an IDE, which is like an integrated development environment. It's just an application where we can code and you get some benefits from it. It'll give you little squiggly lines if it thinks you're making a mistake, or it'll give you it'll hold your hand and say, don't do that. That's going to break the world. And then finally, you probably have heard of the .NET framework. The .NET framework is basically just a giant repository of reusable components for use in coding. When you're coding, you can bring a piece in from the .NET framework to do that's already been written by Microsoft and does a ton of stuff for you that you don't have to use. You don't have to write yourself. It's very, very helpful. We couldn't do anything without it. We could, but it would take a million years. If you've installed the .NET framework in your computer, you can go see the DLLs that are in there. You go to Windows, Microsoft.NET, pick the framework, pick one of your versions, and all these DLLs that start with system, these are all the pieces that I was talking about. So you'll see here's one that controls Windows forms. Here's one that helps you with web services, serialization. So this is what the .NET framework is. If you hear that term, now you know what it is. Okay, so let's do an overview of how C# becomes machine code. That's the section's title. The section is also titled Super Nerd Fun Time. Getting a life? And what level do I unlock that at? Thought that was funny. Okay, compiling. So basically, you take C# and it becomes machine code through a process called compilation, or compiling your code. It's a process of turning human readable code into machine language that a computer can munch on. Does anybody know what that final munchable language is called? You get 10 points if anyone can tell me what that final.
Compile?
No. Well, it's compiled under its lowest element. It's really simple stuff that only a machine can read. Starts with a B.
Like binary, you mean?
Yeah, binary. Binary. And remember, when you talk about binary, there are those who understand binary and those who don't. See, that's the binary representation of 2. That's why that's funny. So yeah, that's the final stopping point for a machine. It reads ones and zeros. Oh, I'm going backwards, sorry. Here's the whole process at 100,000 feet. So you guys, it really kind of helps. It helped me when I finally understood what was going on. I think I'm the kind of learner that I almost have to know everything to be able to even start. So this just helped me, and I thought it might help someone to know exactly what goes on. So in a minute, we're going to start writing coding instructions in a C# file, in a C# project. And then we push a button, and we basically tell Visual Studios to compile our code for us. We don't have to do it from Visual Studio. It's basically an executable that we could call in a console application. But we say, hey, here's our code, compile it. The compiler begins to run, and it turns our code into what's called an intermediate language. And there's ways to see your intermediate language. It's really pretty cool. But then it just sits there. Nothing else happens until that program actually gets called to run. When it is called to run, there's a thing called the CLR, the Common Language Runtime, that runs a process called just-in-time compilation that finally converts our intermediate stuff into machine code for that specific machine. That's basically the process at 100,000 feet. This is what it looks like in a little flow chart. Boom, 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 intermediate code at runtime. The JIT happens, and you get machine code. So what the JIT? Why the JIT? The reason that is so you remember back in the old days when we used to install programs on machines. We still do that with ASP.NET, but we install the program to a server and it stays there. But you guys remember the old days when you'd pass disks around or you'd pass applications around. Well, every computer is different, and so the JIT compiles your intermediate language down to ones and zeros based on the code, but also based upon what type of computer it's sitting on. So if it's on a 64-bit computer, it's going to give you different ones and zeros. If it's on a 32, if it's on a different processor like an AMD compared to the other kind, and then blah 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 blah. So that's the JIT. So that's basically the whole process. We're at the end. Let's fire up Visual Studio and begin. Anybody remember? Here's another 10 points if anyone can name this movie. It has nerds in it, and you have to be old.
Revenge of the Nerds.
Yeah, buddy. Remember they were drinking and then they'd ride their trikes around in a circle. It was great. Anyway.
Damn it, I couldn't undo my freaking mute. I knew that.
Too late. You didn't get the points. All right. So if you downloaded Visual Studio to look something like this, 2017 looks like this. This is 2015. This is what we're using because it's a lot more stable. 2017 is new, and 2017 is trying to push newer stuff that we don't want to deal with right now. But so the logos will look a little different. But if you did fire up Visual Studio, you'll see this little welcome screen that gives you some news items, what's happening. Here's developer news over here. It's a nice little friendly screen. What we'll want to do, if I get going too fast, if someone's trying to follow along, slow me down. I'm gonna try and take my time here, but I also want to get so you go to File, New, Project. Now, when we do this in Visual Studio is great. There's so much stuff happening for us under the covers. So again, if we wanted to write programs, we could open up Notepad and start writing programs, but there's a whole lot of stuff we're going to have to write just to get it to the point of where we can compile it correctly. Visual Studio will do all that stuff for us ahead of time so we can jump right in and just start writing code. They also set up projects based upon what kind of a project you want. So because there's all kinds of different types, right? There's a console application, there's a web application, there's a video game application. So when we click File, New, Project, you're going to be presented with a bunch of different, well, not a bunch, I didn't download a bunch, but there are a bunch. Well, these are all different types of applications we could start that it just kind of lays the framework down for us. You'll see under JavaScript, there's a Node application I could run. There's TypeScript, which is like JavaScript, blah, blah, blah. So I go back to but I want to be on the Visual Studio. I do not want to be on Core. If this says, I'm not exactly sure. Brian might be able to tell me what this might say. It might say Core something. It won't look like these. We want to be on the .NET framework, and it can be anything really from what we're doing today. But we don't go to the Core because that will use a whole bunch of new stuff that your screens won't look like mine. So make sure it looks like .NET framework up here, and we're just going to do a console app. We're going to call it Happy Fun Game. Okay. And again, not again, but what Visual Studios will do is put it like in Documents, Visual Studios, Projects folder. You can put it anywhere you want, but we're going to call it the Happy Fun Game. And we're about to start coding, y'all. Boom. This is getting real. So there it goes. It's laying a bunch of frameworks for us, bunch of groundwork down for us. You'll look over here on your right-hand side, and here's all the framework stuff that it laid out for us. It created a bunch of files that we need ahead of time, and it's reading a bunch of stuff for us and making things simple. So when we say we want a console app, it creates a program, and it creates a file, and it calls it program.cs. CS. Anybody want to guess what CS stands for? C#. That's right. I could tell. I didn't hear anybody say anything, but I know you all said it. It stands for C#, and that's our source code file. All right. And over here is where we're going to start coding. Now, every program has at least one main. Supposedly you can have more than one main, but you don't really want a main, more than one main. But I read places that you could get funny and make more than one main. But the main is where you're telling the computer to start. That this is where the program starts. Makes sense, right? This is main. So right down here where we have no more space, we're going to make some space. This is where our program's starting. So anything we write in here, we're actual programmers at that point. Before we get started, I want to point up here to what these guys are. So remember what I said a minute ago or a few minutes ago about the .NET framework, right? It's a bunch of reusable components that help you do stuff. Well, whenever you start a new file, Microsoft says, well, you're probably going to need these here. Remember that they were called system whatever, and so it just automatically adds some stuff that you might need. Right now, we're not using any of it. You can see they're all kind of dark. When we start using one of these, it lights up. You don't want things in here that you're not using, but it throws some generic stuff in there to just say, hey, we think you might be using some text, or you might be using a bunch of stuff that's here in the system thing. So that's .NET Framework right up there trying to help you. So back to our main entry point. Let's start coding. Let's write the word console. Now you'll notice a whole bunch of things come up here, a bunch of options. That's some of the goodness of Visual Studio. It's called IntelliSense. It's like, are you trying to write this? Are you thinking about doing that? And so we're making a console app, and let's just start writing a phrase to the console. So to do that, we would have to call console. You'll notice that system lit up because this whole thing here was made inside of system. Stop me if you have any questions. I don't want to jump ahead. I don't want to be losing anybody. But right now we're simply going to write a line in the console. So console is a whole other application written in system, and it has a bunch of things that it can do. One of the things it can do is write line. And it's going to, anybody want to guess? That's right. It's going to write a line. Well done. So we're going to say, woo-hoo. We wrote a program. All right, and so basically this is a line of code. You said, hey, we want to write a program using the console stuff. We know this is going to write to the console, and you'll notice that it takes what's called an argument. It's, well, if you're going to write a line, what are you going to write? And so that's that's what we wrote in here. We're telling it to write this line. Hopefully that makes sense to everybody. If anyone has questions, stop me. Now, we can't just run this right now. We can, but we're not going to see our line because what's going to happen is the program's going to start at main. It's going to run through the program, and it's going to end. So what you would see is you would see the console pop up. You might see the line, but it's going to go so fast, it's going to just close itself down. We need to stop the program from shutting itself down. So we're going to write another line, another command. So let's write a command to make it not shut down. Anyone know what that command is, or have any idea if they've used it before? Okay. We're going to say read line, which is going to make the console wait for input, which means it won't shut off. All right. So there we go. That's a program. That's going to do something really cool. So right now we can go to build and build our solution. Remember, this is the process called what? What's it called? Yes, compilation. Right. Good job. So we're going to compile. We compile the program. There it goes. It's doing all those things I just talked about. Build has started. All the stuff's happening, and she's done, Jim. We saw that she was done. So let's go out to our documents, Visual Studio, projects, happy fun game, and let's find our program. If you go into, whenever it writes the program, it writes it to the bin directory and the debug little folder. So there's happy fun game right there. That's great. You can, if you know anything about applications, you'll see it says it's an application because it's an exe. So we can click it and we can run it. Let's do that. Oh my gosh. Is that glorious or what? There is a program. You notice the cursor sitting there waiting for user input because we told it to read line. And so I'll hit enter and it shuts down. Do I still have, I think I hear snoring. Is anyone still awake? That's great. Everyone's falling asleep.
Oh, we're here, man.
Okay, good.
Compiling go too.
I'm feeling like, I'm feeling the pain that Marjorie and Sean feel all the time. It's like, I thought I heard tumbleweed go by. Scary. It's a little scary out here, Bart. All right, let's keep going then. So we've written a line, we've read a line. You guys are like, big deal. Let's see what else we can do. So I'm going to bring in a couple lines here. Actually, you know what? Before I do that, well, we called this a game, so what should the game do? We're going to make this game pick a random number and we're going to guess it, right? No one's ever thought of that game before. It just came to me out of the blue. So to do that, we need to do a couple things. We could write a random number generator ourselves, or we could look and we could see if the .NET framework has a random generator, and they've already written it for us. Let's just look and let's see if there's, oh, look at there. In system, there's a thing called random. So it's already done this for us. Oh, there's even random number generator cryptography. I don't even know what that is. I'd have to look that up. That looks cool, but we're not going to do that because I don't know what that is right now. There's so much stuff out there, guys. You don't even know. So to create a random number, we need to create something that's going to hold that random number, like a container that's going to hold that number. To do that, that's called a variable because it's going to change, and it's like a little holder that's going to hold our number that we pick. So we write var for variable. We need to give it a name for our random number generator. So we're going to call this random number generator. You notice it's camel cased, right? Or I'm sorry. You see I went lowercase, uppercase, uppercase. This is what we call when we say code conventions. We do things in certain ways, and it all has reasons for it. It makes it easier to read and to understand. And so this is called camel cased, and we do this a lot in programming. So we're going to call it random number generator. We're going to say, hey, we're creating a variable, random number generator, and here's what it's going to be. It's going to be a new random class. All right, so now we have our random number generator. Let's see what all it can do. So we hit random number generator, we hit the dot, and we see what it can do. Oh, looky there, it can do next. And Visual Studio is great. It's going to tell us exactly what each method or function is doing. So we could go down each one, and it will give us a description of what each one is doing. But we just want whatever this one is. We want return a non-negative random integer. So we're going to pick next, and then we have a couple different options. We can do a min-max value. You see that here. The integer's a min, integer's a max. That's the one we want. Let's go 1 to 100. All right. So guys, at this point, oh, you know what? What did I do? I forgot to put that in anything. You see the blue squiggly? That blue squiggly helped me out. It's like something's wrong here. You're just putting a number, and it's just like disappearing. You see on the left-hand side, the number's just falling off. It's falling off into eternity. It's not going anywhere. What do we need to catch that? We need another variable, right? So we'll call it random number equals, and there we go. Yeah, I hear noise. Is that a question? Okay.
Sorry, my chair.
Got me all excited. I'm going to move this down below because I want to find out what the number is. Let's just see if it's really a thing. Let's go console write. And let's see what that number is. So now I can write a little, see I put quotes, I can write a little string, but I want to do something called I just had a complete mind. I say this a million times. It's it's not string concatenation. Just never mind. Man, that makes me mad that my brain just did that. String interpolation. Thank you. Whenever you want to combine an actual like string with real stuff, you can use the newest convention is to use this cool little $sign. Now I can write something and say your cool number is, and I can do the curly brace like that, and I can just call out random number right inside my quote. Oh, you see how I highlighted that? It knew that I was talking about that. So let's compile this. Go back to build solution. Now I'm going to do something different. I'm going to open up a console, and I'm going to have it go straight to because I don't want to have to keep double clicking. I want to just keep this open. So I'm going to change my directory to where that game is at. And I'm going to look at the directory, see if it's in there. There's Happy Fun Game. It's an exe, so I don't have to write exe. All I got to do is write Happy Fun Game, hit enter, And boom, there we go. Woohoo. We wrote a program. Your cool number is 31. That's awesome. If I hit enter, it shuts it off. Let's try it again. Look at that. It's a different number. That makes it more fun. Still, ooh, that was kind of close. Weird. So all right. So we're at the place where we have a cool random number, and we have a statement that says woohoo. I don't like that statement. I wrote this a couple days ago. Let me bring this in. Write whatever you guys want if you're following along. Welcome to an awesome number guessing game. So we are at 2:30. I was trying to figure out where we're at. All right, so let's move on. We've got string interpolation. You've got random numbers. You're writing stuff in the program. What's the next thing to do? Why don't we get user input and see if we can guess our own number? How's that, right? So to get user input, we need to read a line and then see what it is. So let me see. What should we do here? We should probably tell our user no, that's sexist. You should please guess a number, friend. All right, now I told you earlier this is actually looking for user input. One cool thing so this is a function. These are all different functions that come off of a console, and they all do different things. So you'll notice this is a neat little thing. When I hover over read line, do you guys see to the left of where it says console read line to the left? There's that blue word, string. That's telling me what's going to come back. That's telling me that read line is going to return to me a string because it's reading the line, right? This may be, I'm sorry if I'm way too basic for some people, but I'm trying to be as basic as possible because this can be confusing to some. But it's really neat to me. It tells me exactly what's coming back from that function. Now look, if I go to write line, I get back void. That doesn't sound good. Basically, it's nothing, right? Why would it be anything? There's nothing to return. There's nothing to give me back. So I don't try to catch anything here. I haven't been trying to catch anything here. Sure, Eric, thanks. I haven't been trying to catch anything here because I haven't really cared what happened. But now I do. And I know that it's giving me back a string. So I'm going to make something to catch that string. So we're going to call it play or guess. Right? And there you go. It's going to retrieve the string from play or guess. And we could write another line if you guys want. Let's just do that just so we can prove to ourselves that it's right. We're going to do our string interpolation. We're going to say you guessed, and remember our curly braces? We can do play or guess, and boom. And then we're going to need another read line, or else it's going to shut down on us. So, little annoyance of doing a console application, but actually, because we're doing it this way, we still could read it. So we don't actually technically have to have this. Let's just not. So here, I'm going to do something that's called commenting. You might have heard commenting code. You should comment your code. People used to say that a lot, and then people commented way too much. So you don't hear it as much. You should write your code in a clear, concise way so that it comments itself just because it's written intelligently. However, sometimes you need to add some comments. So when you write two slashes like that, you see it goes green. I could say anything in the world, blah, 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 and the compiler ignores that line. That's a comment. So I just commented out this read line because let's not use it right now. So I saved it. I hit Control S. I can do like that. I can build it, which is F6. You notice they all got these awesome shortcuts on the right-hand side. And so it just built it. So let's go back here. And happy fun game. Your cool number is 23. Please guess the number, friend. Well, I'm going to guess it's 52 or 54. Right? And I'm going to hit enter. Look at that. You guessed 54. So hoping everybody understands, and I hope everyone's not completely bored, but that's where it's at. And you notice because we got rid of that, we didn't need it because we're doing it this way. So it did end the program, but we're still right here. We can still read it. If I do it this way, this is what I'm talking about. When you do it this way, it just shuts itself down because it's finished. Okay. All right. Let's keep going. Let's move along. We're getting close to being done with phase 1. So player guess. So now we've got a guess. What can we do with the guess? Well, we can do anything we want because this is programming and it's awesome. So we can evaluate. We can see if this guess is anywhere near the actual number. So to do that, we write an if-else statement, an if statement. Like you do a million times in your head a day. If tummy growls, go get food. If am grumpy, go get coffee. Those are ifs, else. You're a computer and you're doing if else statements all day long. So we're going to write one right now. We're going to say if player guess does not equal, that's the symbol for does not equal, right? Random number. Then we're going to do something. And what we're going to do is say you're a loser. We'll say wrong. You lose. Goodbye. Or, so the other thing we could do is, well, we're doing an if. So what's the opposite of an if? If this happens, great. But if not, we do an else, right? So if else. And there's more options than that, but I'm just showing you. So if this doesn't happen, else, so what does that mean if we're down here? That means they guessed right, doesn't it? So let's goodbye. Right? So let's test that. Does anybody see something going on right now? Red squigglies. Red squigglies are your friend. This is Visual Studio saying, Todd, you got something jacked up here. Right? It's saying something's wrong. What does it say? So you read what this red squiggly tells you. It says you can't apply the operator not equals to types string and int. I would love someone to come off mute and tell me what's going on here if they can. If they know. If not, I'll give it 10 seconds here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, never mind. So one of the main things in computer programming are called types. You have things we try to emulate the real world in our programming. We have classes of things. It's called object-oriented programming. We have classes, and the classes do stuff, and there's types also involved in this whole thing. So one type is an integer, a number. Another type is a string, right? Another type is a Boolean, a yes or no switch. So there's a bunch of different types. What I'm trying to do, what the computer's mad at me here doing, is I'm trying to compare a string with a number. See, this returns, if we go to random next, remember that blue word I was telling you about? Right there, you see that blue word says int. It's returning an integer. So random number is an integer type, but player guess is what? A string. So I'm trying to compare two things that are wrong. So I need to do something to make this work. I still want to do this. How can I do this? Well, the one way I can think of, a good way, because I want to make them both numbers so I can compare to see if they're close. So eventually I can tell the user, you're close, you're not close, you need to go up, you need to go down. So I'm going to convert this string to an integer. So look, again, system.NET Framework, they made something for me called convert. Let's see what convert can do for me. There we go. Here's all these things I can convert to. I want to convert to an integer 32, right? And so I can put all these things in here and make it an integer 32. So I'm gonna throw in the string. Now I wonder how many people I lost here. This looks kind of funky, right? But basically, I'm getting a string here, and inside of my string here, I'm converting it to a number. So now watch this. When I hover over player guess, it's going to tell me It's an integer. See the blue? Because the outside function is changing it to an integer. And my red squigglies went away. Beautiful. All right, let's run it. Let's see if this works. I'm going to hit F6 to compile. Go back to my console app, run it. And I know what my number is. Let's try not to do the number. I'm going to do 54. And looky there, wrong, you lose, goodbye. Our if-else statement worked. Let's see if our if-else statement works the other way. This is called testing. This is one aspect of programming right now. I'm testing to see if it works. If I hit 81 right now and it tells me I'm wrong, I know I've got a bug in my program, right? So I hit 81 and it says yes, goodbye. There we go. All right, and so I know right now that at least that simple if-else statement is working. Trying to see, I've got an outline on my right-hand side. That's why I keep pausing, guys. Sorry, I want to get through some of this real basic stuff this time and see if we want to move ahead the next time. So I'm just trying to read through my outline, blah, blah, blah. Oh, okay. All right, here's something else I wanted to show you. Let's go back to our program, and let's run it. Happy fun game. And let's say, please guess the number, friend. I'm going to guess Farfanugan, because just Farfanugan. Oh, what? I just got a whole bunch of words. Oh, look at that. What's going on there? I just blew up the world. What happened, y'all? It was expecting, you guys know what happened?
You gave it a string.
Right. Well, I gave it a string, and then what? I gave it a string that wasn't able to be converted, right? So you're right, absolutely. I think that was Joe. So I gave it a string that couldn't. Oh, go ahead. I'm sorry.
No, it's Doug. Sorry. Yeah, you gave it a string that wasn't converting into an integer.
Exactly, Doug. Thank you. Yeah, because this expects a string that can be converted. So it tried to convert Farfanugan, and it was like, I have no idea. I don't know what Farfanugan is. I don't know what number that is, and it blew up. So you guys probably have seen. No, I don't want to do that. You guys have probably, in our code, highly likely you've seen things like this happen. And it looks like a bunch of garbage and gobbledygook, and it freaks, well, what is that? But there's actually real information in here. It took me, a while, even as a programmer, to just want to sit down and read this stuff because it's so ugly. But it tells you exactly what happens. So when you see these things, whether you're a developer or just a layperson that knows a little bit about developing, you can read through this and probably get some pretty good information. Right here it says system format exception. The input string was not in a correct format. And you're like, okay, well that makes sense, but what format was it looking? Well, right here it tells you string to number. It was trying to convert a string. So you could intelligently, if you get something like this and can read some of these more intelligently, file a bug saying, hey guys, in here you weren't checking. What should we do, right? We should, in this situation, and this can happen on the web, we could be asking them to give us a phone number or an address, some sort of, give me your age, but we're not checking to make sure they didn't give us, letters. And then this could blow up just this exact same way. And so if you can read these and get through stuff like this, first of all, if you're seeing these things as the complete outside user, that's a problem. We shouldn't be, this stuff shouldn't be seen. I know it does get seen. And if you ever see an exception like this, you should report that, because we should catch these on our end and handle them much better. But if we're not, and you see this, you can tell us exactly what happened, or what you think happened, or what it's telling us, and where it's at. And so that's an exception. Okay, so we got 15 more minutes. Do you guys want to try and press forward to do hints? Or do we want to save this till next time? I figure this might become a quarterly thing if people are interested. Maybe want to jump way deeper. You guys let me know. I think we could definitely continue forward and do some help, give the user some help by giving them hints. You're too low, you're too high. What do you think? All right, good input. Don't care. I'm going to press forward then. Let's see if I can get to the hints location, and then we'll stop right there. All right. So let's hide the answer first of all so we can stop seeing it ourselves. You guys remember when we want to hide stuff, we just mark it out.
Okay, Todd, can you hear me now?
Yeah.
Sorry about that. I've been having a hard time with unmuting. So I'm going to say yes to yes. I think we should definitely keep doing this quarterly. Absolutely.
Awesome. Awesome. This Chris?
The one and only.
All right.
Well, unless you count Tuesday.
I got my attendance collapsed and hidden, so I figured that was you. You sound happy like you normally sound, so that's good. All right. Fantastic. Thanks, Chris. Well, let's just press forward real quick. In another 10 minutes, we can make this a little bit better, and then maybe we can build on this, or we can trash it and jump to something else, but we'll deal with that later. So I'm going to hide the number so we don't see it every time. I'm going to just mark it out. One thing you never want to see when you are a programmer and you come into somebody else's code is a bunch of this garbage left around. You never want to leave unused comments. If we're gonna comment something, it needs to mean something. But a lot of times you'll come into sloppy code and you'll see just commented lines out because the developer commented it thinking whatever and then forgot to take it out, and that just makes your code a mess. You know, you don't want that if you ever become developers. You want to keep your code as clean as possible because over the months, the weeks, the months, the years, code can become horribly sloppy if you're not vigilant with what you do. But that's a sidebar. All right, so right now we know we have an if-else statement that says, you know, this tells us whether they got it right or not. So what we want to do is we know they didn't get it right if we're in here, correct? So let's build on stuff in here. You know, yeah, I'll do that, and then we'll move this into a separate function inside of our class next time. But let's just build on this, okay? You see this green squiggly? Some of you might be asking what that's for. There's another way that you can write this if-else statement that makes it a little bit smaller. It's called a shortcut method. I'm not really we use it all the time in our code because we have a lot of experienced developers. But you don't want to use it. I mean, depending on what your team looks like, you don't always want to use the shortest thing possible, because here I'll just show you. If I was to go ahead and do what it said and convert it to that method, it looks like that. And that's not super readable. It might be less lines of code, and it might do the exact same thing. But if you've got a bunch of junior developers on your hands, they're gonna have to stare at that. What this is saying is, hey, let's console write line, and in here it's doing the if else. So I'm not even going to explain it, actually. Just never mind. Let's just stay with this. This is a lot more easy to understand. So if we're in here, we know these guys are not correct. So we can do another if, and this may or may not be a good idea of doing nested ifs, and there's better ways of doing it, but I'm just trying to show you. All right, we know it doesn't equal. Let's see which way it doesn't equal. So we can just use basic math stuff, right? We can say if player guess is greater than random number. You guys are probably following me at this point, right? And I'll move this right line so we can give them hints. Say wrong, too low. Or else, if we go to an else, we know that it's below it. We know it's not equal to it, right? Or we wouldn't even be in here. So we know it's below it. So we're going to say wrong, too high. Okay. Now we need to get into one thing called do a loop. There's loops. Loops is another thing that you can do in programming. You can loop through code so many times, or you can loop through stuff based upon certain conditions. So what we need to do, if we just leave it like this, we're going to get one shot at the guess. Oh, you know what? Let's just run it, make sure that this works. So let's run happy fun game. Please guess the number. We're going to guess 50 because you just want to go right down the middle. That's an algorithm, a real algorithm. You guessed 50, wrong, too low. Wow, that was fun. Game over, right? So we add a loop. There's a do while loop that says while something is true or not true, do this. So and I haven't checked this syntax ahead of time, so hopefully I get this right. It's been a while since I've done a regular do while, but let's just try it. So let's create a variable that holds the fact of whether we have won the game or not. So let's call it game over, right? And game over, is it over right now? No, we're going to say game over is false. So this is holding. Anybody know what type game over is going to be? That's right, it's going to be a Boolean. Okay, it's going to be a Boolean. It says struct. I don't know why it says struct. Well, system Boolean. Struct, true, false. Okay, so a Boolean is a struct. All right, never mind. So, while, we're starting our loop here. We're going to say while, man, that was a bad idea. Instead of calling it game, that's going to be awkward syntax. So I want to say while game's not over. So game not over. This is probably not the best way to name it. While the game's not over, so I need to change that to true because I want to code in the positive. So I'm going to say while the game is not over. Nope. I'm going to say while the game is not over. Here's my loop. I want to continue to do all this stuff until while the game is not over. Is the read line in here? Where's the read line? No, read line's in here. All right, I need the read line in my do while loop. So it's going to read my line. It's going to tell me what I guessed, and then it's going to evaluate, right? And it's never going to stop until the game's over. When's the game over? This would be when the game is over, right? So right down in here, we can say game not over now equals false because the game is over. I didn't test this. This is a shot in the dark. This should work. This isn't that tough a code, but I always like to think it through before I go live and show people. So let's see if this works. So happy fun game. I'm going to pick 50. And look, it didn't finish. Woohoo. And it tells me that I'm too high. So let's using the algorithm that I can't think of splitting the difference, let's go to 25. 25 is too high. So 13. What you got? Hopefully this is working and isn't broke, but I'm pretty sure this is working. You notice that the do while it continues to ask for. So as soon as I pick a thing, I hit enter, it reads it, it evaluates it, and then it starts another loop. So what? All right.
Hey, I got a question for you. Maybe this might help. Does it keep randomly selecting a number each time you do that, or are you still working on the same number?
No, that's a great question. But you'll know up here is where I pick the number. It's outside of the loop. So no, it doesn't do it every time. That's a great question, though. It did continue to say too high, though, and that's interesting to me. So we have a bug. We know that the player guess wasn't the random number, so let's undo this so we know what it is from now on. If player guess is greater than the random number, then
you don't have the less.
Say it again.
You don't have the less than.
Well, but that's the else. So if it's not greater than, then it has to be less than.
Right. Oh, okay. I see now. Okay, never mind.
No, you're great. That's great. Actually, so here's one thing we can do. We can run. All right. So I've been running this.
Isn't your stuff backwards? So if player guess is bigger than the random number, then tell it wrong, too low.
Yes, ma'am.
It should be too high.
Yeah, you're right.
Else, right, too low.
So it was. Oh, well, that would make sense. Why I was going the wrong way. Thank you, Marjorie. Thank you.
I'm here for you.
Yeah, but it got me to a place where I remembered we could do what's called debugging. This is one of the greatest things about Visual Studio. So I'm running this straight from the program, but I could run this from within Visual Studio, and I could have stepped through and seen this. This is really cool. Let's just do this real quick. So let's pick 50, right? I hit enter. Now you see what I do is I put a red dot on the line that I wanted to stop the debugger at. So we're not there yet. Let's hit boom. Boom, it stopped. This is so great. Now I can actually hover. I can see that my guess is 50. I can see my random number is 40. And there's a bunch of things I can do. I can step into, I can step over, I can step out of. I'm going to step into this. So I'm going to hit F11 because I want to see what happens. Okay, good. It did what I thought it was going to do. Now, is this going to do it? This, I think this is going to step in because guess is higher. And there it goes, right? So let's see how this works. So it went through that. It gave me that. It's done with the if statement. It's back to the while. And it's going to say, is game not over? I can hover over game. It's still true. So here we go again. And there we go. So let me take that off. So we know what it is, right? 40, you guessed it, game over. Let's pull this out. Let's play the game one time and we're done. This is going to be so great. Marjorie gets a gold star for really paying attention.
Logic, man, that's my bag.
This is right up your alley then. All right, guess a number, friend. Anybody want to guess? You want to play, Marjorie? You do it.
Oh, am I starting from the beginning?
Yeah.
I like your way of doing it. I'm going to have to go with 50. 25.
Oh, no, not
13.
again.
Is it still broken?
No, I don't know. I don't think so. Let's see. 13?
13? Yeah.
Oh, there we go.
Oh, there we go. So let's go with 19. 15. So 14.
Boom. That you were terrible. 1, 2, 3, 4, 5. No, that's good. 6 tries, and we win. So, guys, we're right at an hour. That's a lot of basic stuff, but there's a lot in there to munch on. I mean, with the .NET framework, with basic loops, types, variables. I hope it was worthwhile to y'all.